Hello everyone. I'd like to talk about the map data type again, which we started talking about in class on Monday, but it's very important and has tons and tons of applications, so there's not enough I can say about it. Now we'll talk about the data type first, and so I'll just focus on the implementation of a map in C++ without worrying too much about the details of the implementation, but we'll just focus on the data type. So like I was saying, a map is an unordered collection of keys paired to values. So in this particular example, the keys were strings, and the values were actually vectors or flexible lists of numbers. And so I was thinking of this data set here was like the favorite classes to teach here. So I was saying, my favorite classes to teach at Ursinus are this class, 373, Theory of Computation, 476, 477. Actually, I should add 271 to that as well. I really like data structures. Okay, so anyway, but the key is the string, Chris, and then the value is that list. And then we have another object in here, or another pair of information, which is Bill. And he is paired with the list 173, 374, and 475. And then finally we have, in this particular example, we have the pair of data Anne Marie, which is the key paired to the value 170, 274, and 275. And there's no particular order to these. I can shuffle them all around. The important part is that I should be able to look up the values for a particular key. So there's a couple ways to think about this. So a map can be thought of as, a collection of pairs of information where a value is glued to a key. Another way to think about it is like a dictionary, where you look up some information about a key. So here, this would be like a dictionary where the entries were our names, and then what we were looking up was the classes that we taught. You can also think of them as functions. A map really represents a function. So, it really takes an input, which is the key, and then it gives you an output, which is a value. Or, yes, there's many ways to think about this. You could even think about it as like an array of some sort with indices that are arbitrary object types. So here it's like an array where the indices are strings, and then we just index it by the string, and what we get back is the value. So there's a bunch of different ways to think about this. When I think of it from the point of view of a function, that is helpful to emphasize the fact that there is only one value paired to a particular key. All right? So there's only one output for any input. There's no such thing as duplicate keys with different values. So you're not allowed to do that in this data type. Okay, so every key has exactly one value associated to it. Okay. So that's the data that I had floating around, and here's how I set it up in the STL map. So STL comes with the map class, which is templated. This template actually takes two classes because we need a class type for the key. We also need a class type for the value. And notice the class type for the value itself has a template because this is a vector of ints. So it's a template within a template. It's like template inception. I mean, mind blown, right? Look at that syntax. That syntax is a bit ugly. However, the syntax for accessing, the value associated to a key is quite nice. We would call this syntactic sugar, because actually it looks like just indexing an array, but I'm indexing the array by the key. So I'm looking up here, what are the courses that Chris likes the most? So Chris is the key, and then the value that I would get back would be this vector list of course numbers. So once the data structure is set up and I've inserted, or other languages call it put, once I've put in the key value pairs, I can then look things up very conveniently. I don't have to search through the whole thing looking for them. That's not my job. I'm just supposed to say, here's what I want, and then the data type gives it back to me. Okay. Now again, this is an abstract data type, so I haven't specified any of the implementation details. It's really just like an API. So at some point when we go to implement this, we are going to have to worry about how do I find this key quickly, right? So these keys exist in like a sea of keys, and I need to find the key quickly, ideally, so that I can give you back the value. Okay, but the data type itself is already a little bit novel. So let's take a moment to focus on another example just of how to use the data type before we worry about implementations. So in class I was talking about that choose your own adventure game, where we had something called it's called a finite state machine. This is something that we'll talk about a lot in theory of computation, those who are taking that. But it's just you have these finite locations, and then you have transitions that you can follow between them, so these arrows. And so this was representing a depressing scenario of my life during quarantine teaching, where the locations were different places in my apartment. And what this data was modeling was the data you need to make a choose your own adventure game, where it's a completely text-based thing in the console, and you would loop through some kind of while loop, and it would tell you where you are. It would tell you some lore, as Matt said in class, some information about where you are, and then it would tell you the options of where you can go next. So if I were at the office, it would say, hey, you can go to kitchen or you can go to bathroom. If I'm in the kitchen, it would say, hey, you can go upstairs, outside, or back to the office. So that's the information. Now, I want to separate here the data from the implementation of choose your own adventure. So I'm mainly going to focus on the data now. Implementing the choose your own adventure based on the data would just be a matter of creating a loop, outputting the appropriate things, looking appropriate things up, and following transitions if they're valid. But actually, the real, I think, trick here is setting up the right data type for this. So if I jump over here, let's think about it a little bit. There was actually a couple ideas that we came up with in class. So let me hash both of those out, so to speak. Ooh, that's a pun, because we're going to talk about a hash table implementation of this. But yeah, let's try to see how to do this. So one idea that somebody had was, okay, well, first of all, I think we can all agree that the keys, so we're going to use some kind of map, and the keys here, the things that we're going to look information up by, are just the string names of the rooms. Okay, but then there's a question about what the values might be. Now we started off talking about, well, okay, are the values just like the lore, right? Some information about the place. Well, that's good, right? So that is something we would want to look up. So if I'm in the office, I want to say the place where you frantically try to get everything ready for class. Like, that's some information I would want to know and look up to print that out. But I also need to store the arrows. So we talked about how I need to store the string, but I also need to store the other places that I can go to. And so there's a couple ways to do that. So the value can't simply be a string. It really has to be a collection of strings. So one idea was, well, let's make this a vector of strings. And the first string is the information about the place. The second string is, the first arrow. So the string of the first room I'll go to. The third string is this second arrow, and so on and so forth. Okay, and so then I can store all the information I need, because, okay, I look up the room, then I get back a vector which has, if I'm consistent about it, I say, okay, the first element of that vector is always the lore, the description of where I am. And then the remaining elements are just the other places I can go to. So let's look back at our syntax here and see how this works. I'll just copy this over as an example. But we're going to tweak this a little bit because, okay, so the key is a string still, but actually the value is a vector of strings now, not of ints, because we need to store all this text. Okay. So let's see here. Let's try to just start by adding the office here. And then in an exercise, I'll have you add some other things. So, okay, so let's see. So the office would be called office. So that would be the key. And then the value would be, okay, so first the description, the place where you frantically try to get everything ready for class. Unfortunately, that hasn't changed too much, even after quarantine teaching. Okay, anyways, so let's see where we go next. We're able to go to the bathroom, and we're also able to go to the kitchen. So I'll just add those as elements to the list. And that's it. So, okay, let's make sure that compiles that. So go ahead and try to compile that. And so I'll pop open my terminal here. Try to compile that adventure.cpp. I'll call the output file adventure. And it didn't compile, so what did I mess up? Let's look. Oh, of course, I have to change the template type of the pair also. Okay, so the STL map also has this type pair, which pairs information together. I need to change that to a string. Okay, let's see. Did that fix it? Okay, yeah. See that? So the horrible cascade of errors that you get from STL went away with a change of just one little thing. All right, so that's one way to do it. Another idea that somebody had in class, which is quite nice, was we could actually create a class to encapsulate what it means to be a location. And so in this class, I'll just make everything public for ease for the moment, but in this class we could have the lore, and then we could actually separate out into a different piece of information the arrows. So it's the same information, but now it's a little bit maybe more elegant than storing them all in one flat list, where it's a little bit easier for me to see in syntax what is the lore and what are the arrows. All right, so I will have you try to add a couple things using this class now, and then we'll continue on to talking about how to implement this.